I am Sujita from first year CSM department. Now I would like to explain the topic about synthesis and applications of conducting polymers. In this conducting polymers, I will explain the introduction of conducting polymers, examples of conducting polymers, conditions to become conductive, synthesis of different conducting polymers, and applications of conducting polymers. First, what is meant by polymers? Polymers are very large molecules made when hundreds of monomers join together to form long chain. Uh, polymers word comes from the Greek word poly means many, mers means parts. Example polybutadiene. Next one, what is meant by conducting polymers? Conducting polymers are organic polymer that conduct electricity. Next, and connecting polymers have an extended p orbital system through which electrons can be moved from one end to other end of polymer. Some examples of the conducting polymers are polyacetylene, polyphenylvinylene, poly, polypyrrole, polyaniline, polythiophene. And now in this slide I am showing some important examples of conducting polymers. These are special polymers that are able to conduct electricity just like metals or semiconductors. Some common conducting polymers include in this slide. First, polyacetylene, polyaniline, polythiophene, polypyrrole, PPV. Polyacetylene, one of the earliest and most widely studied conducting systems. Polythiophene contains a sulfur atoms in its structure and shows good stability and conductivity. Polyaniline, very popular because it is cheap, stable, and easy to prepare. Pyrrole, widely used in sensors and batteries. PPV, used in lead and in industrial methods. The next one, conditions to become conductive. There are two main conditions for a polymer to become conductive. First one, conjugated structure. The first condition is that the polymer must have alternative single and double bond along the backbone. This type of arrangement is called conjugative system and it allows electrons to move freely along the chain. Here you can see the alternate single and double bonds which create a pathway for electron movement. Now next one is doping process. The second condition is doping, which means adding a chemical substance that increases the number of charge carriers. There are two types of doping. First, oxidative doping, next reductive doping. First one, oxidative doping, where the polymer loses electrons. It is called oxidative doping. Example, polyacetylene doped with iodine. Reactive doping means where electrons are added to the polymer. Example, polyacetylene doped with sodium. Okay, next, synthesis of different polymers. Synthesis of different polymers. First one is synthesis of polyacetylene from acetylene. This method is uses as a Ziegler-Natta catalyst. The reactant here is a acetylene. Now I am explaining the reaction. This produces a polyacetylene, a conjugated polymer. The key point is this is one of the classical and widely used in industrial methods. The next one is synthesis of Byring opening method. This is polymerization. This second method uses as a group catalyst. Now, applications of conducting polymers. There are many applications of conducting polymers which is given as used as anti-static substances for photographic films, used as corrosion inhibitors, used in compact capacitors, used in transistors, used in light emitting diodes used in sensors, used in solar cells, used in display screen of mobile and mini format television screen. These are the applications of conducting polymers, some applications. And the factors that affect the conductivity: temperature, mobility, presence of doping materials, some factors that affect the conductivity. I am showing the in this slide the effect of temperature. And the last one is conclusion. In this topic, I concluded the conjugated polymer or semiconductor material which doped which doped polymers are conductor. The conductivity of the conductive polymer decreases with falling temperature in constant to the conductivities of typical metals. Example, silver, which increases with temperature. Today, conductive polymer being developed for many uses. Next, last. Thank you.